All right. Good afternoon, everyone. We from Group One will present our work on analyzing data using Microsoft Excel. The data that we analyze is data on airplane crashes from 2006 to 2009. Our group consists of Fadil Mitama Karim, Anya Yasid, Ruben Robani, and Najwa Rashika. And this presentation contains a description, data characteristic, statistic, data visualization, correlation, and data cleansing. All right. The description, we analyze plane crash data from November 2006 to May 2009. This data includes the date and time of the accident operator, location, plane type, flight number, registration number, route, number of passenger aboard and fatalities, and summary of the accident. This data is in XLSX format taken from dataworld.com. In this data consists of 188 rows and 11 columns, and the file size is 124 KB. And the next one is when we first downloaded this data, the data is an untidy state consisting of only one column, and the attributes were separated by commas. And this is what we do. First, we block all data. Then in the data menu, we select text column. Then we fill this section with commas. And this is what happened. Our data is organized and already consists of 11 attribute columns. All right. And data characteristic. This data characteristic consists of date or date of the plane crash, quantitative attribute, time, or time of plane crash quantitative attribute, and so on. And finding maximum and minimum value. So first step is a block of data that we want to find the maximum and minimum values, and select a conditional formatting menu. Then choose top or bottom rules, and then choose more rules. Step number 2 is we can find the maximum and or minimum value. If we want the maximum value, then we select top, and also we can determine what the maximum value is. If we only need one data, then we can enter the number 1. And step number 3, yes, that is the process of finding maximum and minimum values of data. This is maximum and minimum values of attribute, time, aboard, fatalities. Okay, the next statistics.
So for these statistics, we obtain standard deviation, mean values, percentile, extremum is the maximum and minimum values, and frequency from Microsoft Excel. Next. Okay, for the mean value and standard deviation, so these two correlates to each other. Mean value is the average of the data. For this, we're going to look for the fatalities and people on board values because it is numerical data. And then what is actually standard deviation? So it is a measurement of how dispersed the data or how scatter the data to the mean value. So to obtain the mean value first, we use the equals average, and we block the cell of fatalities. And then for the standard deviation, we use STD, EVs, and then block the cell of the fatalities. And then we do the same for the people on board. And then the result is the number of fatalities has mean value of 17.2, and then the standard deviation of 31.3. And then for passenger on board, we have mean value of 25.16, and then standard deviation of 43.5. So the higher the standard deviation means means more scatter is the data from the mean value. Next. So on the percentile, so percentile is the lowest score that is greater than a certain percentage. For example, the 10th percentile means the greater data that greater than 10% of the data. For here, we also look for the fatalities and passenger on board since it's numerical data, and then for the fatalities, we can see here the 10% is 1, and then 25 is 3, and then so on. Next. Here is how we obtain the data. We use function percentile and then block the cell for the fatalities. And then things to mention here is the condition. So the condition here is after we block the cell and we add semicolon and then 0.1. 0.1 here means the percentile of 10%. And then for 25%, of course, is 0.25, and then 50%, 0.5, 0.75, and 0.9. Next. For the passenger on board percentile, we use the same with the same function with condition of the percentage, but instead we block the cell of the passenger on board. Next. Then the extremum, we obtain the minimum and maximum value of the fatalities and people on board. We use the function of equals min and then block the cell of the fatalities. We got 0 and then max and then block the cell of maximum fatality, sorry. We got 187 and then we do the same, but blocking the cell of the people on board or passenger on board, we got 1, and then the maximum is 214. Next. Then the frequency, we want to compare the how many of the plane crash happen in range of times. So here we use we want to know the how many plane crash happen before and after 12 a.m. So for the before 12 a.m. we use the count if and then we block the time, and then we use here the condition is semicolon and then quote less than 12:00 means it's less than 12 a.m. and then for the after 12 a.m. We use the greater and equals to 12:00 is for the time. And then we want to know how many plane crashes happen from a different operators, since there is military, commercial, and private. So we use count if, and then the condition here for the commercial or private, we use less than and greater than, and then stars military. It means it's excluding the military, so it will read the operator outside the military, and then we got 160, and then for the military we use condition here quote military to see. So the data here indicates that there are more plane crash happening after 12 a.m. and then there is more plane crash happening from the commercial or private operator. Next. Yeah, data visualization will be presented by Anya Yasin.
All right, for the data visualization, okay, we just go to the next slide, please. We have category comparison, and for the first category comparison, I use the frequency of crashes and the manufacturer type. So what this data tells us is that other manufacturers, other than the ones written here, it has more crash rates than the ones that are present. Manufacturers like Tupolev, Rockwell, Mi-17, and Embraer has the lowest frequency of crashes. I think it is around 2. And yes, we could just skip next. To obtain this, we use the countif function, and for the criteria, we can select all the rows and columns, and for the criteria, you can just write Antonov, and to find the frequency of the crashes, it'll just see how many times Antonov is written on the table or the Excel sheet. And so after we find that, we visualize it by selecting all the data pressing insert and choose the columns or the kind of visualization that we want, the kind of charts. For this one, I use the bar chart. So I would just pick the column bar chart. All right, for the second comparison, I use fatalities and the operators. Well, this bar graph, basically, it just means that that the commercial or the private operator, it has more fatalities than the military ones. And yeah, this just compares that, visualize it. You can see that there is a significant difference. You could just next. And also how we obtain this data, Najwa already explained it. I'm not going to explain it again. Long story short, we'll find the columns, and yeah, you can just visualize it the way that I already told you, which is pressing insert and then choosing the correct or the visualization that you want. All right, this one is the showing over time visualization. And for this one, I chose the year and the crashes. And what this graph means is just telling us that at 2008, it has above 60 crashes. 2007, it has somewhere between 50 to 60. 2006, it has 50 crashes. And the important thing that this data tells us is that 2008 has the most amount of crash, and the 2009 has the least amount of crashes. Yeah, that's it. Also, I chose to present it as well with a pie graph so that it can show you the percentage out of all of the crashes. You can see that crashes in 2008 contributes to about 33%. Crashes in 2006 contributes about 20%, so on and so forth. And yeah, you can see again that 2008 has the highest percentage, and 2009 has the lowest percentage. All right, obtaining the chart, the same, you do it the same way. The criteria, you just change it to the criteria that are needed. You need to find the data first, make it tidy it up a little bit so that the graph won't be all messed up. After that, you can just pick the visualization that you want, and you'll get the charts. Next, yes, showing over time. The next one, I chose the frequency of the crashes by the time, the interval of the times of the hour at a day. So at a certain hour from 12 to 6 p.m., the crashes is higher. It's about 67%. So yeah, from 2006 to 2009, at the time period of 12 p.m. to 6 p.m., it has the highest crash rate, which is 67%. And the lowest crash rate is from 12 a.m. to 6 a.m., which is 17 crashes at that interval of time. All right, also for this one, I also used the countif function. Najwa also already explained how you obtain the data and the frequencies. And yeah, you basically just do the same thing again for the visualization. Thanks. All right, Ruben.
You're still on mute, Ruben.
So from this tree map, it can be seen how often crashes happen from each manufacturer or each type. And the one that has the highest area is miscellaneous manufacturer or others, followed by Antonov and Cessna. While the one with the least area, which shows the least amount of crashes, is Embraer, Tupolev, Rockwell, and Mi-17. Next. After that, we can see the percentage, the relationship between the amount of fatalities and the amount of people on board. So looking at the amount of people on board, it's 98%, while the amount of fatalities that happen after the crash happens is only 2%, which is quite small. Next. And next we have a correlation graph. This is the correlation of people on board and fatalities that happen. And as we see from the chart, the R-squared value is 0.56, and that means that there's only 50% correlation between people on board and total fatalities. This because an R-squared value of 0.5 means that approximately 50% of the variability in the outcome data cannot be explained by the graph. And we got this graph by simply highlighting the data and inserting a scatter plot. Next. And this is the same as before. However, this shows the correlation between the people on board and the amount of fatalities on the ground. And it shows that the correlation is very small, which is 0.01, which is close to zero. And that shows that there's almost little to no correlation at all. That's
All right. The last chapter is data cleansing. Is this data dirty? Overall, this data is not dirty. It's just that there is some data missing in several attributes, namely the time attribute with 12 missing data, the operator attribute with 1 missing data, the flight number attribute with 150 missing data, the route attribute with 5 missing data, the aircraft attribute type with 1 missing data, and the registration number attribute with 14 missing data. And this is the formula for find missing data. And the conclusion is that overall, our data is not dirty. This is indicated by the absence of a space at the beginning of a word in the attribute, so that the data is regular. And also the spelling begins with a capital letters. In other words, there is no data that is interval in all capital letters or data with all lowercase letters. And this is, for example, this is uh, not our data, but this is the example that all lowercase letters, and this is the proper, and one is the proper data, and the formula is this. So okay, all right. Thank you for your attention. Our presentation has been delivered. I hope you can take a benefit from what we have delivered. Thank you for your attention and good afternoon. Okay.
Yay.
okay.